Hello, everyone. Mr. K here again. Talking about a hot topic today, something that's pretty highly debated. It's going to be engine oils. And I'm going to try to not shed my opinion on anything. I will be, I guess, shedding some opinions of some what I would call industry experts that I've talked to and share some facts that I know with you. However, you could disagree with this, and you could probably find 100 articles disagreeing with what I'm about to say. You could probably find 100 articles agreeing with it. This is something that industry experts disagree on, oil companies disagree on. They put out frequently asked questions parts on their websites, and they don't agree with each other. So I'm just going to tell you what I know from experience, and I at least want you to get a good understanding of the different viewpoints and just some of the basics that people do agree on, like what the ratings mean and all that. All right. So I put these little argued or not argued at the bottom of the screen here, bottom right of the screen, so you can just get an idea of what you can always quote. And this stuff isn't argued. We're going to talk about purposes of engine oil, the engine oil weights or motor oil weights, conventional versus synthetic, API and ILSAC ratings and what they are, non-detergent mineral oil and what that's for, as well as industry expert. We're going to throw an industry expert interview in there. That is 100% true. That I actually interviewed a guy several years ago who's an industry expert in oil, has designed many oiling systems, and we'll get to that. Anyway, interesting stuff. So first thing is the purpose of, I need to delete greases. This originally was both, but it was just too long, so we're just doing oils. But purposes of engine oil. Not argued, of course. It lubricates. I think that's probably the first answer most people would give. It cools cools a lot of parts in the engine. Removes contamination. That makes sense, right? It carries things away with it and carries them to the oil filter. Prevents corrosion. I would hope that's also mostly common sense. Transfers hydraulic energy. This might be where it starts getting a little confusing for you. An example of that would be cam phasers. There's a lot of cam phasers that changes the camshaft timing, and that's using oil pressure to drive them. And it seals off cylinder compression. Bet you didn't know that. That is why you need to put a crosshatch in cylinders when you're rebuilding an engine. That actually holds oil, which helps seal off compression. All right, again, not argued. Motor oil comes in various weights. You can see at the top we've got a 020 and a 2050, and then at the top right we've got SAE 30. So those weights correspond to different viscosities. Viscosity is the thickness of a liquid. I don't have it in here, but viscosity is measured in centistokes or centipoise. That's what it's called. Just like distance would be measured in inches or feet, viscosity is measured in centipoise. And just as an example, water is 1 centipoise. Peanut butter is like 200,000 centipoise. Motor oil is around 1 to 200 centipoise, which is the same as like maple syrup, I think. That gives you an idea. So that first number, the 20 that has a W, W stands for winter. The first number is ideally what the oil should, the viscosity of the oil should be when it's cold at, I believe it's, 32F, what it should correspond to. And the second number is what viscosity that should be at 212F. Now, keep in mind, that does not mean that the oil is going to get thicker as it gets hotter. Oil does not do that. It gets thinner, more like water. The reason that second number is higher and that corresponds to the hot is because that's corresponding to a higher grade, a higher viscosity rating oil. So when that oil is when a 2050 oil is at 32 degrees, it's going to act like SAE 20 oil. When it's at 212 degrees, it's going to act like SAE 50 oil. Hope that makes sense. And use the correct weight recommended by the manufacturer. So we're going to watch a video on this, hopefully explains a little more, but I'm going to ask you right now, why would this type of oil still be made? Because this is pretty much what everyone uses. This is what every manufacturer, almost every manufacturer is going to spec out. And they say this is the best of all worlds because when it's freezing cold out, the oil's thin, so your engine can pump it more easily. And when it's real hot in the summer, the oil stays thicker so that it protects better. So why would they still make this? And the answer that I want you to give there, I want you to think of, is that in air-cooled engines, such as lawnmowers, they still spec out, they'll still say, even a brand new lawnmower will say fill with SAE 30 or SAE 40. There's a variety of reasons for that, but just know that some engine manufacturers, particularly air-cooled engines, because air-cooled engines are hard on oil, which is a whole nother story why, but those will spec out or ask you for an SAE oil and not a 20W or 0W type oil. All right, go ahead and pause my video and watch this one at this time. All right, that video should have talked to you a little bit about viscosity grades. Hopefully you understand it a little better now. But if not, here's another slide, again, not argued. So these are two different SAE oils, but all I really want you to get out of this graph is that it's a linear curve, I guess you'd say, or no curve, because it's a line. But the relationship between the viscosity of an SAE oil and the temperature is linear. So as the temperature rises, the viscosity falls, just in a line, okay? Now what I want you to see here is that it's no longer linear, right? There's a curve in each of these plots. So as the temperature, let's just use this 20W50, as it starts off here pretty thin. Let's see, at 40 degrees Celsius, I'm sorry, pretty thick. It starts off at about 150 centistokes. As it warms up, it falls down to, as it warms up to 100 C or 212 F, it falls down to below 20 centistokes. If you were to take SAE 20 and put it on this graph, it would look something like that. Because again, up here, it's going to intersect, because that's 20 W50, so it's going to intersect there when it's cold. But the problem with SAE 20 is that it falls off the grid and it gets really thin when it gets hot. So why not use SAE 50? SAE 50 stays thick when it's hot, but when it's cold, it's off the charts in viscosity. So your engine's got to work way too hard to pump it when it's wintertime. There's where the 20W50 shines, because it catches it there and it catches it there. Go ahead and stop my video and watch this one at this time. Okay, you should just watch that video. Hopefully that gives you just a good representation of how the thicknesses can really change how oil flows. All right, the moment you've all been waiting for, conventional versus synthetic. All right, good. I'm glad my sound worked. Okay, so conventional versus synthetic. This is something that's debated. Well, cheaper is not debated, it is cheaper, but this slide has some things that are debated on, and I'll try to point those out to you. It's cheaper, we all know that. Here's one thing that's debated. Conventional motor oil, if you take a paintbrush and you paint that onto a piece of metal, and then you paint synthetic motor oil of the same weight onto that piece of metal, and you hang them up and you let them sit for a week, in theory, the one with conventional motor oil will still have a layer of oil on it. The one with synthetic oil, almost all that oil will have dripped off and will be laying on the ground under it. That's what that means by metal adherence and less drip down. Another thing is conventional oil is good at swelling seals. So in old cars that have old cracked brittle rubber seals around crankshafts and valve stems and things like that, typically you want to use conventional oil because it helps to swell those seals and keep them soft and sealed up tight. Now synthetic has more of a detergent effect. So synthetic will clean your engine out better. If you have an old engine that's full of sludge, some people will put synthetic in it and then they'll pull the valve cover every 100 miles or 500 miles, and they'll document how much it cleans up the motor. Also, synthetic is better known for like turbocharged, real high temperature and crazy applications because it maintains its viscosity better at extreme temperatures. It's supposed to be healthier for an engine that is exposed to extreme temperatures, I guess you'd say. And of course, that goes along with less breakdown, so the oil doesn't degrade as quickly, again, from heat cycling, which can give you longer oil change intervals, which we'll talk about that. That's debated also, but just know that it's argued that synthetic is one way it's better. All right, another thing, that's another slide with some debated material here. But first of all, you might be thinking, well, what's the bottom line here? This is confusing. Bottom line is really you should just use what the manufacturer recommends. Most of the time, the manufacturer wants their vehicle to last long so that you'll be impressed and you'll buy another one. And they know what's going to treat your engine the best, so just do what they say. But if you still want to know more, let me break it down some more. Conventional. A lot of people say use that if you're changing the oil every 3,000 miles because you're saving money. You don't need that extended oil change interval. Use on engines without turbos, superchargers, just plain engines, which is on most cars pre-2000s. And use on vehicles that were filled with conventional from the factory. So if you have a 91 Ford Explorer, it probably came from the factory with conventional oil, not synthetic. I wouldn't switch it. If you switch it, you're probably going to start having some issues with leaking. Some people say that's a wives' tale, but I can tell you that I have had that happen several times with several old vehicles. As soon as I switched them to synthetic, I started seeing leaks on the ground. All right, so synthetic used for extended oil change intervals. We talked about that. Using high performance engines with turbos, superchargers, that type of thing. Use it if you're trying to clean out sludge from an engine. And people say it's slipperier, so use it for maximum miles per gallon. I don't know that it saves you a ton, but people say it does save you a little bit of money on gas. All right, here's a slide this stuff's not argued. So how do you know if an oil is good quality, right? There's a million brand names out there. You're gonna look for something called an API rating. API stands for American Petroleum Institute, okay? That is an organization that does testing on oils. They're separate from all these companies. They're not owned by Mobil or Motorcraft or Valvoline or anything. They're separate from all those. And they test oils and for, how much water do they absorb? How much heat can they handle before they break down or start smoking? Just all kinds of things like that. They run tests and they certify oils. And if they certify an oil, say it's good, it will have a donut rating. They call it a donut, but it'll have that rating on it. Okay, something that looks like that. It may say SM as in Mary, or it may say SL as in Lincoln. But generally speaking, if it's got this donut on it and it says S something that's in the alphabet past, let's say F or H, it's a decent oil. There's also an ILSAC rating, and that stands for International Lubricants Standardization and Approval Committee. That is the international version of API. So it's not just American. This is, I think it's mainly Japanese based, or maybe China, but that's a committee that's, again, not associated with the United States. And they're saying, hey, we think this oil is cool. It's good. And their rating is going to look like that. It's going to be more paragraph form. But you can see this is off of, I think this is actually off of Valvoline Container. And let's see, there we go, ILSAC GF6A. That's the latest and greatest ILSAC rating. Generally ILSAC GF5 or later is considered to be pretty good. Here's what it's going to look like. I think this is 10W30. Yeah, there it is, 10W30 API certified SP, I believe that one says, or might be SN. Oh yeah, SN. Yep, there it is, SN. And ILSAC GF6A. So that would be considered a good oil. Okay, how about this one? SN 820W50 API SN Ilsec GF6A. Okay, so that's a good oil also. Notice this one says resource conserving. This one does not. This one is a thicker oil, 20W50. That's not considered a resource conserving or a high mileage or high gas mileage oil because it's thicker. It's harder for the engine to pump the oil throughout. This is a good video. It's long. It's eight and a half minutes, but it's good. So go ahead and pause my video and watch this one at this time. All right, you should just watch that video. Hopefully that gave you a good overview of all the stuff we've been talking about. One thing we haven't touched on yet is this non-detergent motor oil. Why do we need non-detergent motor oil and what is it? Non-detergent motor oil is also called break-in oil, also called mineral oil. This is used when you have an engine that you've freshly overhauled or rebuilt and you are going to break it in. Engine that's freshly rebuilt needs to be broken in. Depends on the manufacturer and what you've done, but at least about 20 minutes of break-in with this type of oil. Now, this is, of course, someone's opinion, but we'll get to that. It's called non-detergent motor oil for a few reasons. It doesn't have a lot of additives in it. It's supposed to be actually a harsher oil for your engine. It's less slippery, and it allows for increased wear, which is a good thing during break-in, some people will argue, because it allows the piston rings to seat properly. Also doesn't hold contaminants in suspension as well. You can argue a lot of reasons for that, but the theory behind it is that most oil will take a little chunk of metal and hold it, or I'm sorry, it'll grab it and carry it to the oil filter. When you're breaking an engine in, it may sound funny. You actually want those chunks of metal shavings to hang out for a little bit because they help the break-in. They help speed the break-in process of things in the engine because they wear the high spots off a little faster. I'm not saying it's the best idea, but it is believed in by a lot of people. And it is actually common practice in aviation when you're breaking engines in. All right, last thing I want to do is tell you about an interview with an industry expert in the oil industry. And this is not someone that works for an oil company, so I kind of trust him a little more. You can go on YouTube and find dozens of people from Shell and Valvoline, all these who are interviewed, say, oh, you have to buy this oil, you have to, but I think they're just trying to sell you something, or they could be. This guy has nothing to sell. This is actually, his name's Brad Potier. He's been, for many years, been an oil systems engineer for Chrysler at their headquarters in Michigan. Some of you who are watching this video and know me know that I used to work there as an engineer. And I actually sat right across from, I sat in the next aisle over from Mr. Potier, and I had quite a few conversations with him on oil and oil systems. And this is how one of them went, probably the most notable and the most important for you guys to hear. I said, Brad, what kind of oil should I use in my cars? Because, of course, synthetic and conventional is a hot ticket. So should I use synthetic and conventional oil in my cars? And he basically said, kind of what I've said in this presentation, unless you run a turbo or you're just pushing the engine to the max, like you're racing or something like that, it really doesn't matter. You can run conventional, just make sure you change every 3,000 miles. That's the most important thing. I said, what about brand name? What's the best brand? Is Valvoline and Shell and Pennzoil. He said, just change your oil every 3,000 miles. I said, okay, fine. What about these additives like zinc additives, high mileage oils, oil stabilizers? Do I need that stuff? Just change your oil every 3,000 miles. That is how the conversation continued over and over again. He said, nothing is more important than changing oil every 3,000. And if you do that, you don't have to worry about any of that other stuff. You don't need synthetic. You don't need additives. Just change it every 3,000 miles. Now, why 3,000? Well, that's kind of an arbitrary number it was picked long ago for reasons relating to contamination in the engine and things like that. But let's go back to it. What if you have the best oil in the world? And this was Brad's point too. When I asked him, I said, what if I get this oil that's $40 a quart and guaranteed for 20,000-mile oil change intervals? He said, change it every 3,000 miles, because it doesn't matter how good the oil is. It has nothing to do with it. The oil gets polluted. Okay. It's just like pure water that you're going to drink. Doesn't matter how pure the water was if you have dumped, salmonella in it, and there's algae growing in it and all that stuff. Doesn't matter how pure it was to start. It is now ruined after you pollute it with those things. Same thing. Great oil gets ruined in 3,000 miles. It gets byproducts of combustion, acid, vapors, fuel dilution, gasoline goes by the rings and gets in the oil, condensation from it sitting and changing temperature environments, water in the oil from combustion, a whole variety of things. The acids that break down the oil from combustion, again, byproducts, carbon, bits of carbon and things like that from combustion. All of that pollutes your oil. Even if the oil itself is still good, it's severely polluted. If you continue to run that, it is worse. He said that actually the worst part of it is plastic in your engine and the nylon. So timing chain guides, cam phaser stops, things like that, it ruins those prematurely. Certain seals, rubber O-rings, that type of thing ruins them prematurely, and you're going to have leaks, you're going to have things not working right, and it's all because you didn't change the oil every 3,000 miles. So for what it's worth, that's an expert's opinion. All right. So hopefully that sums up for you and you know something more about oils now. Long presentation, but actually it wasn't. It was less slides than most of them, but there's a lot to talk about with oils. So on that note, I'm going to end it there and have a good day.